In this example, we're going to use the formulas of discrete compound interest and continuous compound interest again, and this time we'll be looking for the principal. So this might be an example where, I don't know, let's say you are planning on getting a nursing degree, and you know it's going to take a certain amount of money to do that. Let's say it's $45,000 to get your nursing degree. So you think, well, I'm going to start saving now and set some money aside in an account that I expect to grow. And we'll just say the growth rate of the account, hopefully, is 7.5%. We're going to give it 6 years. And let's say this account compounds quarterly. Okay, so every quarter of the year, you will be given some interest by the mutual fund or whatever the institution is, and that'll be added to your account. So the question is, what principal investment is needed? What's the initial amount of money you need to put in this account to have it grow to $45,000 at the end of 6 years? So let's use the discrete compound interest formula first. And I will say, let's just write it down here. A equals P times 1 plus R over N to the NT. And let's say A is $45,000, and P, we don't know. R is, remember, a percentage gets turned into a decimal by dividing by 100. So this is 0.075 divided by 4. And N is 4, so that's 4 times, what's T? T is 6. Okay, so let's go ahead and calculate some of these numbers. 45,000 is not going to change. That's staying right there. We don't know what P is yet. But the inside of this parentheses is, let's see, 1 plus 0.0775 divided by 4. This is 1.01875 to the 24th power. So that is 1.56179. Okay, so if I know that 45,000 equals P times this number over here, all I have to do is divide each side by that number, and I will get P by itself. This is just solving an equation. We've done this a lot of times before. So let's divide 45,000 divided by 1.56, and what I get is $28,813.07 is your initial investment. So I put in 28 grand, 29 grand, and after about 6 years, I expect that'll be $45,000, enough to start a nursing program. So that's the idea of using quarterly interest. Let's try it again for compound or continuous compound interest. So I'm going to say A equals PERT, right? And A is this $45,000 number. I hope the degree doesn't cost you $65,000 by the time you're done saving for it, or that'll be a little life change. P E R T, so R is 0.075 and T is 6. So now what we do is we calculate this, and in your calculator there's an E button. It's usually along the left side column. You usually have to hit the second button to find it, or the shift button, whatever your calculator function uses. I'm going to type in 0.075 times 6 in my exponent, and what this returns is 1.568,312. You'll see that's actually close to the number from earlier, 1.56179, but this one, 1.56832, is a little bigger, indicating that the growth is faster if you use continuously compounding interest. And now I'm going to divide each side by that number, and what I get is my initial investment has to be $28,693.27 if I expect this to grow to $45,000 at the end of 6 years.